yesterday, so you already heard an introduction of them, but you, the ones that did not. Greg Laughlin is now working at the Lick Observatory. He received his PhD in astronomy and astrophysics at the University of California, Santa Cruz in '94. After that, he had held postdocs in Tokyo, University of Michigan, and also at Berkeley. Then he went on to work for NASA as a planetary scientist for 2-3 years.
Yep.
Yeah. And then he came back to University of California, Santa Cruz, and Lick Observatory in 2001, and became professor in 2007. Today he's going to talk to us about how we are progressing toward observing Earth mass exoplanets within perhaps 1 year.
1 year.
Yeah.
For Earth mass exoplanets. So thank you for the talk. This talk will be a little bit different from the kinds of talks that you sometimes hear. The seminar is different from the talk that I gave yesterday because astrobiology sort of draws together a lot of different disciplines. And so I'm going to try to talk at a level that everybody finds informative rather than either being too technical or too simplistic. So this is the one slide that I showed yesterday that I'm going to show again today, just because this I think really gets the point across of what we're going to try to make today. This is a plot of all the planets that we found around nearby stars, in which I've plotted their discovery year versus their mass. And what you notice about this, a number of things. First of all, the hundreds of Jupiter mass planets, or planets with masses roughly similar to Jupiter, have been discovered. There is actually, seems to be a bit of a shortfall of planets in this region. We'll talk a little bit more about why that might be later. And then on this semi-log plot, the lower envelope of detections for the last 20 years actually is quite well fit by this line. And it's only a small extrapolation to the one Earth mass point. And so if you extrapolate this and assume that this sort of Moore's law for extrasolar planets continues, then we're going to find our first Earth mass planet orbiting a nearby star within a year or so. And that's quite a remarkable thing. It may be that that planet gets detected by one of the space missions, CoRoT mission or the Kepler mission, and it is equally likely that that planet will get detected using a radial velocity technique from the ground. I think it's a 50% chance that one of those two techniques is going to be responsible for finding the first Earth mass planet orbiting another nearby star. Now that first Earth mass planet that gets detected within the next year or so is going to be hot. It's going to be 800 degrees on its surface. It's not going to be a habitable planet, but it will be an Earth mass planet. The first habitable planets are probably 3 to maybe 4 years out. And I'll talk a little bit more about that. Now, if you read the news, you would get the impression that for instance, huge news, first possibly Earth-like extrasolar planet found. As planets are discovered, and in particular, as the lowest mass planets found to date get discovered, so this planet, this one, and this one, each time one of these guys gets discovered, because it's the lowest mass planet yet found to date, it's the most Earth-like planet yet found to date, and so the media gets all hyped up and excited. And so there's a bit of a danger, in my mind, that we're, to use the English phrase, jumping the gun in the beginning of a track race. If you get off the blocks before the gun goes off, you're jumping the gun. And these articles and ones like it, I think, are kind of doing that. And so the question that I'm interested in this, I was talking to Robert about this earlier, this has sort of a wider utility, is when should we really get excited about the first Earth-like planet? When will we know when we've really got a planet that is worthy of headlines, that's worthy to really feel like we are on the threshold of a new era? I've been sort of thinking about that, and we've recently launched the Kepler mission. So the Kepler mission is flying. It's working great. The first data that's come from it has been extraordinary. Hasn't been released yet, but it looks great. And the Kepler mission is going to find something like 50 potentially habitable Earth-sized planets. Okay, that's what its expectation is. It was flown with that expectation. And it cost about $600 million to fly the Kepler mission. And so what that means is that society as a whole has put a value on knowing about extrasolar planets, Earth-like extrasolar planets. Society as a whole has said that we're willing to pay taxpayer money, $600 million, to find something like 50 habitable planets orbiting 12th magnitude stars. Now, what's interesting is if you diverge slightly from the planets that Kepler is going to find, you're going to either increase or decrease the degree to which you get excited. If you detect a planet around a 21st magnitude star, you can't really get that excited about it other than the fact that it's there, because you have very little opportunity to follow up. You're getting very few photons from that star. You're not going to find anything interesting about that planet other than the fact of its existence. Whereas if you find a planet around an extremely bright star, then you're getting tons of light from that star. You have the opportunity to do follow-up observations and really learn